Okay. So what we're going to do today is we're going to finish up the chapter on text mining and specifically look at several different exercises that you all can do yourself. But I thought we'd start with that. Then we're going to move on to databases. The first one is just creating a word cloud, but it may have spin-off benefits. And what I mean by that is I can foresee that this little engine here, where you retrieve PubMed abstracts, might be valuable for your research or some other purpose. So this search engine, don't forget about it. In other words, all you have to do is you put your email in, click OK, you put whatever, I put COVID-19, you put find records, and it thinks for a while, and I think it's going to come up with actually 100,000 records, which is more than I care to look at. And then you click abstract, because that's what we want to mine, is just the abstract, if you will. We could have done title, it would have been fine. And then you put retrieve records, and that the number it's going to retrieve is whatever you set above that. We set 1,000, so now we have 1,000. So that's really easy to do. And then what I've done here, let me see if I can move this menu down. I'll keep moving it around, is I've set up a dual pathway here. And what I mean by that, I've set up a pathway to look at the word cloud with no pre-processing, and then look at the word cloud with pre-processing. But first things first, let's just look at a corpus viewer to see what it looks like. So let's just pick an abstract. So there's an abstract, just what you're used to seeing. That's what we're going to be looking at. So if you do a word cloud without cleaning up the data at all, what you're going to see is the following. Now, in the
where did you get that corpus from? Maybe this is something you've done before, and
okay, let's go back. So, and I apologize because you're new. Text mining, you open, and you may have to add that to Orange, by the way. You go up, see options.
I see.
Add-ons. And then you scroll down to text.
Okay.
And make sure you have it. And this actually says there's an update. I haven't done it yet.
Okay.
Every time you use Orange, you actually should go up here and see if there's anything new. But I'm glad you asked that question, because basically you have to check the box and then you have to restart. It'll install it, and then you restart it and it'll show up, okay? So for all these text mining, they live in this module over here called text mining, the corpus. And it has, by the way, notice the New York Times, PubMed, Twitter, what else? Plus you can import your own documents. It has The Guardian. So it is a way to mine stuff if you get really into NLP. As I sort of hinted before when we started that chapter, NLP is a little bit like image mining. It's a full-time job to get really good at it and understand all the terminologies and be able to use it on a regular basis. So basically, getting back to that question, is we just drug the PubMed widget out here. There is a corpus viewer. We drug that out. We connected it. The corpus viewer just basically is a viewer of whatever you have in this widget. And then word cloud, I'll go back to here. And you might wonder why this is a little different than my original book chapter. The answer is I got different results and I couldn't reduplicate it. Meaning before, when I processed it, I got rid of a tremendous number of words. This time I got rid of mainly stop words, but let's just finish with this. So this gives you words and weight over here to see. You notice that the is the most popular, no surprise there, and so forth. So in other words, you got a lot of noise, not just signals. So in the pre-processed text, which you drug out also from the text mining, we basically checked everything. We want everything to be lowercase. This is a language that says select all words, basically. It gets rid of stop words here by checking that box, stop words like the, and, of, and so forth. And also it stems the words. So fishing would end up being fish. It just shortens it, if you will. So that is your pre-processing, if you will. And so basically you still have a fair number of words, but I think you'll notice that it's much cleaner with words that reflect a medical focus much more, like patient, COVID, pandemic, health, disease, and so forth. And then you can look over here, COVID and COVID-19 and 19 were the most popular. So that's just an exercise. If you ever needed to do a word cloud, you have that ability. And also there may come a time when you'd like to see other abstracts from PubMed. All right, the next thing is not my specialty, but as you know, sentiment analysis is very popular, looking at tweets to see if you can pick up trends. So let's open Twitter. That again, this widget lies inside of the text mining module here, right there. You drag that out, you connect it, and let me open it though first. You have to apply for a Twitter API key. You just click on it. And it took me less than an hour. And then you have to input some stuff they send you, kind of like a password. You input it and you're good to go, okay? So the query word list I used was COVID, vaccine, and sentiment. Maximum tweets 1,000 is what it was. You can connect a data table to look at it. So this is what an unfiltered data table looks like. In other words, let me, again, move my menu out. So you can scroll over, and as you get over, let me also put, okay. If you get over here, you'll notice there's missing data, but you'll also notice, again, menu keeps getting in the way. But you'll see positive, negative, neutral, and compound comments. That's what we're going to mine, basically. So let me get out of there. So you might say, well, how do you get rid of the missing, the tweets that have missing data that you want to mine? The answer is you have a column positive, and you just say, positive is not 0, negative is not 0, neutral is not 0, compound is not 0. So basically, you want all those tweets that don't have negative values. And then you want to only mine positive, negative, neutral, and compound. So you basically move all these other columns that you don't care about over there. But again, you may have a different search or you're trying to do something different. I doubt you're interested in longitude and latitude, but you might be. You could continue that and mine that. But for the purpose of this exercise, we're just going to leave these intact. That's all we're going to mine. So here again, a data table, so you can take a look. You can see the content or comment or who did it. Positive, negative, neutral, and compound. And we'll talk about compound, which is basically a composite score. And then you connect this to a heat map. It isn't intuitive, I have to admit. I wouldn't have known to connect it to a heat map. But so here's a heat map. And if you look up here, you notice blue is highly negative at minus 0.9. This yellow is highly positive at 0.97. So if you want to, and this is a hierarchical clustering, if you will. So you've identified the most negative ones is here. So you just drag it down. Another wonderful feature of Orange. When you drag, you have essentially highlighted all these negative comments. Now you go back to the corpus viewer and you have, let's see, I guess it's actually 74 documents that are negative, but I clicked on one before that I thought would give you an idea how negative. it just talks about Eric Swalwell sleeping with a Chinese spy, so forth and so on. So it gives you an idea of a negative sentiment. And that, again, the compound is what I look at that basically takes into effect how strong is the positive, strong is the negative, strong is the neutral, and you get the score. So make a long story short, it rated it as negative. And you can look at these and play around with them, but that's how they would look at sentiment. You can look at others here. You can see words lying, misinformed, terrorist, and so forth. That's how it got picked up. But that's basically how you would do mining sentiments to try to see what the trends are in something. Any questions about that? Okay, if not, I'm going to move ahead with the.
So, Bob, what decides what is negative and what is positive?
Well, it really is natural language processing, searches the words.
Okay.
And attaches significance to them.
Okay.
I mean, that's basically what it does is it's going in there. And let me just see something.
I guess is there another algorithm behind it that decides already there?
I'm glad you mentioned, I intended to open up sentiment. It uses Vader. You can look that up, but it's just a way of analyzing the tendencies.
Okay.
So that's the mechanism is Vader.
Okay. All right.
Where it does look to try to pick out what's negative, positive, neutral, and then calculates a score for that. And again, it's something that you all can play with if you have an interest in that. It's not an area that I'm particularly interested or knowledgeable, but I see a lot of that in the literature, to be honest.
Thanks.
All right, the next thing is the whole concept of document embedding. The word embedding is the same thing as vectorization. And what that means is, regardless of whether it's an image or a paragraph, a computer can't analyze it. It wants to see ones and zeros. So it will basically take a paragraph. It'll look how common a word is, how far it is away. It can even measure angle. You'll see the word cosine sometimes with natural language processing. It's measuring the angle between words and doing calculations. So it's quantifying what you and I would consider to be qualitative. So here, the file, let me, in that chapter, I pretty well told you what I did. On GitHub, I found several thousand procedural, I don't think they're real, but it's so hard to come up with medical text because of HIPAA regulations. So what this was basically procedure notes. And what I did is I took the first 100 and I rated them myself, what I thought is surgical or non-surgical. And so that's what we started with. And we're going to use the same data set to actually classify it. I'll explain that in a second. So in any case, you've got 100 procedures in here. The corpus, basically, you've got description is what we put in that field. Document embedding, it uses, I think it's called fast text is the algorithm. You use the English language, and mean is a mean distance between words. There's the document embedding here. And then purpose of this is purely just to show you that now suddenly you've got all these numbers, positive, negative. It's converted that text into all these columns of numerical data that I really can't get into, but 300 columns, just so it can vectorize or embed all that content, the 100 procedures, okay? So I didn't really want to get into the mechanics much more than that, except to emphasize we can thank linear algebra for all of that, the ability to convert, again, words into numbers and then analyze the numbers. So using the linear algebra to analyze the numbers using matrices and vectors and so forth. Now let's take that information again, and we have the same corpus, pre-process. What we're going to do is do most of these again with lowercase, pretty well the same thing I already showed you. So we're going to clean it up, get it ready for embedding, if you will. Now, this document, again, we could put a data table in there, which we did up here, and you'd see that some are labeled as surgical and some are non-surgical. This is not perfectly clean. It was all I could come up with as a medical exercise of using natural language process to try to classify the documents. So to classify it, I use naive Bayes, support vector machines, and logistic regression. Why did I use those three? Because historically, 10 years ago, 15 years ago, these were the older algorithms used to do just that. They didn't use XGBoost or random forest at that time. So that's why I did these three. So basically now what you want to see is how good was it? In other words, let me once again move it. You look at, you're going to be interested in this classification and probably the AUC number one. Second of that, you're going to be interested probably in the F1 score. So in this case, logistic regression, for whatever reason, outperformed by a large margin everything else. So you have, again, area under the curve. And by the way, I meant to mention up here, you use average over the classes, and not, notice it's non-surgical, surgical, but they just suggest that you use averages. But basically what you're saying is for logistic regression, it could identify, basically its accuracy was 90% of identifying a surgical procedure note versus non-surgical. Again, there were terms in there that I probably didn't take out. This is probably not a clean data set, but it gives you a little bit of an idea what document classification looks like. And you can do other, we haven't done it in here, but you can do unsupervised learning to go in and look at a data set and try to find groupings. But it was very hard for me to come up again with medical free text that I could use for mining. So I don't have any topic modeling. There's some other exercises that probably would be interesting. I would leave it up to you all to go further if NLP is an area of interest. Look at some other exercises, and you may have to create your own exercise, medical exercise, to do that. Any questions about the exercises that we went over? I give a little bit of explanation in the chapter. If not,
Oh, I think Doreen had a question.
okay, go ahead.
I was curious. So usually in review articles, we rely on high impact factor journals, right? So would there be a function I can work in where I know I only search in PubMed for journals with the highest impact factor? How would I do that?
No, that's an interesting point. I don't know. It gave an advanced search, but let's look. I'm not aware that it doesn't look customizable. In other words, all I saw was URL, abstract, and so forth. I don't know how you would search. In fact, I don't think impact factor is not part of PubMed, is it? I mean, it's part of the journal. They brag about it and put it on their front page, but I don't think that's a searchable item.
Or is it a proxy for number of citations type of thing?
Good question.
Yeah.
I mean, that's
There
a good,
Yeah, because I see in advanced search, it's just a blank text box. I wonder if you know, like, what the variables are mapped to in PubMed, if you can just write your own kind of logic statement for it to filter. I don't really know how this one works.
yeah, I don't have a very good answer. I think you may want to Google that, how to search on impact factor and see what you come up with, because I certainly don't have the answer there.
No, no worries. We're all learning. And the other question would be, how would I narrow it down? I know in PubMed I can do that to filter it down to just the last 5 years or so of publications, or can I do that here too in Orange?
There's a date field that I see.
Yeah, because I used the last year, for instance, just so, for COVID, you don't want too much data. If you put the last 3 years, you probably would have 1 million citations. So yeah, you do want to limit your search by putting in dates that you want.
There are drop downs for you to pick the date range.
Okay, so we're going to move ahead. Hopefully all of you have chapter 15 here. And again, let me comment that this is clearly a rough draft. You may find typos, you may find formatting issues. This is the working document for us to make better. We're open to any suggestions. So if you see anything that you feel should be expanded on, please let us know. All right, when talking about databases, first realize what you're used to is so-called flat files, which are basically spreadsheets, Excel, Google Sheets, and so forth, which for most of the data that we've looked at are perfectly adequate. But when you start looking at millions of rows and you want to network with people and you want to store it, have massive storage, almost always you're going to go to a database system, whether it's a SQL-based database system or a NoSQL. That's another story that we'll cover. But it's just that it's capable of doing more, and hence almost every healthcare organization has several very robust databases. So let's start talking about some general definitions. A database is simply the shell or container for storing the data using a different schemas, how it's organized and managed and accessed. A relational database, we'll go over in a minute, is linked by primary keys, and it's just as it says, it relates one field to another. It's been around quite a while. The most common ones are Oracle, MySQL, SQL Server, Maria Database, IBM, and so forth. And let me just digress for a second. You may want to know, why in the world did you settle on bit.io? I would challenge you to find a simple web-based or client-based database that you can actually use without configuring it and having to launch a server. MySQL is not as easy as someone would think. You have to stand up a server and so forth. So you'll see when we get to bit.io that it's dramatically easier than everything else I encountered. All right, the database management system just simply manages the database. And this is where the database manager would spend a lot of time, of course. The database model, we're talking about really a relational database here, but we'll briefly mention graph databases, which are quite interesting. And then the query language for that we'll use with relational databases is SQL or SQL, and that's structured query language. And we should have time today, hopefully, to start maybe doing 1 or 2 SQL queries. I was hoping that this database would allow everybody to sign on at the same time. The answer, it does not. There's no way to use it. I'm more than happy that you all can create your own instance in the database. It's very easy to do. It's free. And you can play with the exercises that I'm going to go over. A couple of concepts to go over quickly. Certainly historically, they talked about ACID. It's an ACID model, meaning atomicity, which guarantees that once it's started, they're fully recorded. Consistency, that if any element of the transaction fails, it all fails. Isolation means each transaction is completed separately. And durability, it just means that it's permanently preserved. With the newer databases, the non-SQL or NoSQL databases, this really doesn't pertain. So let's move down, and this image explains a lot. This is a super simple diagram. On the left is basically a table of students, if you will. The primary key is the student ID. That's how they're really identified. And over on the right is classes ID, and it lists basically the title and description and so forth. And in the middle, they've joined the table called the enrollments, where they've, if in essence, fused students and classes together. And the primary key there is the enrollment ID. And then now this secondary key is called a foreign key. So the student key is no longer the primary, the class ID is no longer the primary, they're called foreign keys. Also, and I'm trying not to go into too much detail. There's a lot more you could say about it. But for instance, this is called a many-to-many relationship because multiple students can take multiple classes, and multiple classes are offered from multiple students. Also, this diagram is called an entity relationship diagram. You'll see that, or ERD, used fairly commonly. One other concept is called normalization, and there's several layers of it. I'm only going to talk about it in general, and that is in a normalized database, the data value should really only show up once, such as the last name. Notice the last name's not in enrollments, it's not in classes. So a classic relational database just mentions a data point like a lab value once in, say, a lab table. You will link to that table using the table ID, but the value of, say, the hemoglobin does not show up in multiple tables. All right, let's talk again in general terms about NoSQL databases. There are these different types. I'm not going to go into any detail. Document databases can store data in documents like JSON. And the best example of that is MongoDB, which is fairly popular. Again, I'm not going to go into the detail of that. By the same token, key value is a simple database that just has keys and values. An example of that is Redis. Wide column, again, I'm really not sure exactly how that's different from a relational database other than you don't use SQL and it doesn't do joins, but it still has tables and rows and so forth. Cassandra is an example of that. So I think the one I'm going to discuss, and I was hoping Anthony would be online simply because he's a great proponent of graph databases. And the reason is they can handle far more complex information and relationships. So let's look down at nodes and edges. A node is one of these areas that contains information, and the edge is this connector, or it looks like an arrow, that contains the relationship. And so you see here, provider member must be the patient, but here you have health records, you have claims data, you have a bunch of other information. So I would remind people, what about a family history? You could see that in here, relationship between the nuclear family and then the family on the maternal and paternal sides, and potentially you could mine that, in other words. So they are more complicated, and not for the weak of heart, but they hold great promise because a lot of medicine is in fact very complicated. And you can in turn then use a graph neural network and use artificial intelligence to mine that. But that's quite complicated. We're not going to get into it. You can't use SQL to mine it. You use Cypher instead, which is the query language that you would use. Any question about graph databases? I'm not an expert on it, I'll admit, but I think it is an interesting area for sure. All right, let's talk about data warehouses. And I have to give a little bit of a disclaimer here as well. And that is, this is an evolving area that historically all hospitals had some kind of enterprise data warehouse, largely for billing and financial information, or what you call business intelligence, where the C-suite was very interested in looking at all kinds of reports. Over time, that's been modified quite a bit. You now have clinical data warehouses where you would mine largely clinical information. They're similar, but not the same. So you can have registration information, outpatient, inpatient, pharmacy stuff, procedural information, if you will. But there's all kinds of permutations, I guess is the point I want to make. Institutions like I cite here, the University of Pennsylvania or Intermountain Healthcare, have modified their enterprise data warehouse to do different things. The whole idea, I think, though, is to include as much data as possible in one location and be able to mine it and generate reports and generate research. And that's particularly true of the Mayo Clinics of the world that do more than just see patients, in other words. And they may do, again, a ton of other stuff that I mentioned here. Let me try to explain the difference between ETL and ELT for a second. First of all, before I do that, though, maybe I should explain that a newer concept is a data lake. A data lake basically is like a piggy bank with a giant slot. It doesn't care what you put in it. You can put raw data in there, unstructured data, structured data, and usually it's used for research or some very specific analysis by, say, a data scientist. But so extract, transform, and load is when you have a structured database, like, say, an enterprise warehouse. It has a specific schema. The fields are exact. So what you upload has to be exact. So you extract the information from some other location in the right format, you transpose it to whatever is required to match the fields in the database, if that makes sense. So input has to equal the schema or design of that database. So that's extract, transform, then load. Whereas because a data lake has really pretty much no structure, you just extract, load, and transform later. So when you get ready to do your research, then you have to take that raw data and transform it. So that's the difference between ETL and ELT. I hope that's clear. And then the newest one is Data Lakehouse, and the best examples of that are Snowflake and Databricks. And I suspect if you look at any of the gray literature, you've seen those two referred to frequently. Well, the idea, it simply blends the warehouse and the lakehouse, or the data lake, together. It sits on top of either Amazon Web Services, Google Cloud, or Microsoft Azure, and it basically embeds a variety of analytical stuff. In the case of Databricks, it relies on Apache as basically the analytical engine. And from what I gathered, they charge only if you use it. But for the life of me, of course, I cannot come up with any financial data to prove or show that it's cheaper than trying to maintain both a data warehouse and a data lake. It stands to reason it would be more practical and cheaper, but I think it's so new that the jury is out. I'm just simply making you aware that that's there. So this is just kind of a prototypical clinical warehouse, if you will, or data warehouse, where you're extracting information, maybe operational data, financial data, clinical data, billing data. You're going to ETL it into this data warehouse. And then from there, you may create a data mart, which is nothing more than basically a tiny database used to mine some specific issue or problem, whatever that, maybe it's a billing issue. Then all kinds of reports to different areas of the hospital, analytics of different kinds, and OLAP stands for online analytical processing. It tends to aggregate and summarize data, but again, I'm trying to keep this general because this is all evolving, and probably even some of the large hospitals do their own thing. They've customized it to their liking. So that's why this has to be highly generic. All right, so we're going to talk about BitIO in a second, and let me comment that I'm not going to show you how to set it up unless you're interested. BitIO changed. In fact, this is the second version. It's not what I saw back in March when I first started looking at it. You don't need to worry about that, but you have the option here. I've listed how I connected Orange to BitIO. So what does that mean? Using the SQL widget, I could basically connect to BitIO and download a database on there. And so suddenly now I see it in a data table. So it's simply telling you, you can connect Orange to this remote web-based database. And so that's feasible, not necessarily all that easy though, okay? So I'm not suggesting you do that. I think today, unfortunately, I'm probably just going to have to demonstrate stuff for a while. But let's go ahead and look at BitIO. I think, let me see, I think we're ready for that. Literally, when you log on, it's amazing. It just says, create a new database. You just upload the database, log in, you're pretty well ready to go. It's really painless, unlike all the rest. So this one, what you're seeing here, let me go over each thing. I have several databases here. This is the one I'm going to show you right now. And by the way, on the file share, in Dr. Sapsi, if you go to informaticseducation.org, and I can send you all this later, I have multiple downloadable files to include this file where I took several thousand adult NHANES patients with all their lab work and a lot of other stuff and combined it into one large table. Let me just kind of demonstrate that.
Thank you very much.
Yeah, now this is, I'm hoping somebody will actually take advantage of it. Let's see.
Bob, a quick question from Doreen. She's wondering if you can also upload the data as an Excel file.
Yes, it'll accept Excel. CSV seems to be more common, but it'll accept Excel. And actually, I'm not seeing the box. Let me try. Not quite sure. You should be able to scroll over what I wanted to do, and I'm not quite sure why I'm not seeing the bottom here. You should be able to scroll over and show you that there is something like 45 columns because I've combined so many data sets. Anyway, you all can create your own database and do this. So adding new databases is as simple as clicking on this. Connect is where you would connect with Orange. Share doesn't seem to be working. I think this is still in evolution. Share is where I should be able to invite any one of you all in to join. And in fact, initially, that's what I thought I would do, is just upload all the emails of everybody and you could join, but I don't think that's up and running. If you go to documents here, by the way, it's a help menu with the lessons. It gives you examples of SQL as well. All right, so basically, so this is adults NHANES. It basically has a lot of information, and I have converted a lot of the nomenclature. For instance, if you go to any of these like BioPro, let's pull that up. This is all shorthand for NHANES. You have no clue what that means. You have to go to NHANES and look at what each one of these columns. So here, what I did is I, on my own, changed everything. We imported fictitious names because, of course, it doesn't have anybody's names. But for all the columns, I basically put a name that made sense, if you will. So you can look at this vertically, horizontally, you can download it from here. But let's go ahead and talk a little bit about SQL. SQL relies on some basic clauses like select, from, where, age. Let me see how we're doing for time. My feeling would be that we'll do a few queries here and then maybe do this a little bit more seriously next time. But let's just look at that. For instance, what happens if, let's just do a query where what we want to do is we want to basically pull all data, every table from this data set. The wildcard here, asterisk tells it just to do that. So if you run query, it was already up, everything. So that's, tells it though, I want to see every column in there. Two things to warn you about. The data set that you select here, this one over here, has to be in double quotes. That's number one. Number two, for all SQL, and this is SQL, but a variety of SQL called Postgre, Postgre, you have to put a semicolon when you finish your query or it won't. If you don't put that in there, it actually should, it's proven me a liar. It shouldn't pull up. You really should need that. So I don't know why I accepted it. But you do need the quotes, you need this to do it. But let's just give you an example. Let's pull up the last name and the A1C result. You're interested in A1C control, let's say. You run your query. So this pulled up the last name of people and their hemoglobin A1C. You should be able to then do a where clause where A1C is over 7. Oh, well, sorry.
Oh, Bob, I think it's just a typo. You put AIC instead of A1C in the where clause.
Oh, there it is. Thank you. That's exactly right. All right. So basically then, and you have to be careful like that. It's easy to make a mistake. So this is pulling up the hemoglobin A1C levels over 7. And you see some 12s and 15s and some others in there. So you can see the speed of this, that you could do something similar in Excel, but once you get to a really huge database, this is actually faster. And you can also invite other people in. There's other things that you can do with it. But we can go over these exercises, but at a logical stopping point, I wanted to be able to ask you all though, whether you want to finish up this or what's the future direction, because this would be the 15th chapter of the draft book we're talking about. I do have some ideas of what we can do further. If you'd like to see a little bit more SQL, next time we can do that, or on your own. I put in there a great tutorial called SQL Bolt. Pretty well, the exercises I showed you are all based on that. They're very logical, but they use medical data. One more session, we could really finish up doing all of this. But moving forward, I think Dr. Chang would like to see mini topics or journal articles or some future direction. He does, by the way, have a folder of something like 40 important articles that are super current, 2021, 2022, on AI and data science. And we could either present those or we could assign them to people, 1 or 2 per session. So I think this is a good time to really get some input to see what you all feel you'd like to see moving forward. I mean, again, we could do more orange with more data sets. Also, if there want to be more demonstration of working through data. So it's kind of, I need your guidance, whether you want more of the basics or now you feel you're ready to discuss AI in a little bit more detail. Any strong feelings one way or the other?
Bob, this is Ken Blake from Denver. I greatly appreciate this sequence of lectures you've given us. From my perspective, I'd like to see maybe a review, and what I would get the most value out of would be, could you consider us doing a group project, if you will, that we actually worked on, every month online for 15 minutes looking at some problem. And I don't know if we could decide collectively as a group what that problem would be, if we could make that work. Those are my thoughts.
Okay, well, it's not a bad idea, though. I mean, I have, for instance, on the FileShare site on purpose, something called messy data. It is conceivable you all could be given ahead of time a data set problem and asked to do certain tasks and solve for something. That would be worthwhile because it would show you and me whether you really understand it. So I think that to me would certainly make sense. What do other people think?
Yeah, so I second that as well, because I enjoyed in the past, you had some problems and you worked us backwards, right? You have a clinical issue, you have a clinical question, and then how to actually go about finding the answer with the data utilizing Orange. So working it backwards. I'm not sure how much time everybody has outside the 1 hour studying. But I enjoy working in a group together, like a flipped classroom, rather.
Okay.
So, the couple of people who made the proposition, are they implying that we'll not be doing as much homework as just doing that exercise in this dedicated 1 hour, or there'll be a lot more homework? I'm a little bit unclear as to what is being proposed. Or both, I don't know.
Yeah, would you communicate, for instance, would you communicate with each other to try to solve it ahead of time and then report it out,
Yeah.
on a Saturday? Or would everybody be given it and then we would discuss it on that 1 hour Saturday? So which would you prefer?
That's why I'm asking the question. There are a few people here who are, including myself, who have other commitments, and sometimes I can't even make it on Saturday as much as I would want to. But I guess what I'm saying is that at least my preference, I'm only one vote of many, that we use this hour to kind of, make it sort of an exercise. That is one way of doing it. If people want to sit back, if you want to, people want to take homework, then you can propose, and we can do a combination. One month we can do this, another month you give us the same question, and I would be interested to know of how will our results be different, or will our approach be different to answer the same question? And it might be, I don't know.
Okay, well, I do think obviously people's time commitments are different, their approach is different, whatnot. So maybe, how about this as a sort of a hybrid, is that let me come up with a data set that I think is interesting. I will send it out to everybody ahead of time with some tasks. Those people who have the time can complete those tasks. Those who don't can wait till the Saturday when it's presented, where everybody will contribute that has looked at it, and I will contribute, and then we'll try to solve it. So that way you could do it ahead of time or not do it ahead of time. How would that be?
I think that I like that.
Okay.
I'll more likely be the latter group where I just attend, but I'm sure there are other people who can do it at home.
How about a vote? Again, we probably could finish up pretty much all of the simple SQL commands in about 30 minutes or so. Do you all want to do that, or you want to do it on your own?
I think I prefer the first option.
Okay. Because I would say when you compare SQL with Python or R, getting started with SQL is way easier, I think. Not that they're the same, but my point is, it isn't difficult for you to create a database here and to do simple commands like I just showed you, where you're trying to see which diabetics are out of control, let's say, is super fast that you can do, and you can mine that further. So that's why I think it's not a bad it's not bad for people to spend a half an hour looking at that, understanding how relatively simple SQL commands are. Not, I mean, you can make this very complicated. I'm trying not to do that. So if it's all right with you all, what I would propose is the following. The next session, which is probably going to be in about a month, we'll finish up here, and then we probably will have time to have sent out a data set. We'll try to do both. Send out a data set that's got some issues and needs some solutions, and we'll do that actively during that same session. Following that, we'll then try to look at topics and what might be worthwhile, okay? But at least this would give us direction for July.
I like that.
Okay, but in the meantime, though, if you have feelings about, again, what do you want to do with articles? We could also go over national guidelines. I would suggest that as an option, meaning the PRIME checklist is a great one to look at. In other words, what are you supposed to do when you write an article or read an article about machine learning AI? What's supposed to be in there, which often is not in there. So but that means that you actually want that level of expertise. You may not. But I'm just saying there are national guidelines out there. Tripod's another one. Probast is another one. So think about that. You don't have to have an answer today, but just think about it as a possible avenue for more research as well. We could probably do that in 1 or 2 sessions, really.
Well, quick question. Doreen is asking when the next session will be. It shows up in my calendar on July 9th, on the Saturday, July 9th. Is that the correct date?
Let me see if I have that already written. I may not. I do have it as the 9th. Does anybody have an issue with that?
I may not be able to attend, but I don't want to hold anybody up. Like I said, some
These
schedules are hard to compromise. So just keep going, keep having your sessions. I'm assuming they're recorded so that if I miss them, at least I can go with them.
That is correct.
Yeah. So there you go.
Okay. Well, we'll shoot for July 9th, where we basically finish up with these simple SQL commands, and then we'll ahead of time send some data set with the idea of here's what the problem is with this data, here's what I'd like you to do, and then we'll discuss that as a group, okay? We'll try to make that more interactive.
Bob, one more question from Ken. He's wondering, would the lecture notes and chapters be still available online, and how can they access both the lecture notes and as well as the recordings?
Okay, Ken, you don't have chapter 14 and 15. I thought I sent that to everybody, no?
No, I do, Bob, but will they remain available in an online format, including the previous ones? I like to go back and forth. That's just the way I learn. That may be my personal issue. But I did.
And I agree. Same here. I'd like to go back and forth. I can't remember everything with one session.
Okay, but let me clarify. I sent out attached as a Word document to the emails, chapters 14 and 15. You do have that?
I do, yes.
Okay. What is it you're lacking?
I guess the previous ones, as I try to put all this together, I like going back and forth. It's just.
Okay. Well, I mean, I can send you a draft book. It will have some red font. It'll have other stuff in it because I keep adding new content the more I ponder it. I mean, if you want, I can send you.
Spectacular,
Okay.
And
And
what about the recording? Someone asked a few minutes ago.
well, one of the problems was we ran out of space and nobody requested an old recording. I'll be honest. So I kept them. I had to make an executive decision. And so after a month of no request, I decided to delete it. I may have to either buy more space or find some other option. I think you can create a YouTube channel. I don't know if that's a possibility or not.
I like the idea for YouTube channel.
Okay, well, we can discuss that offline. And actually, I'm trying to think, Dr. Sapp, see if I have your email. I don't think so.
I will send it to you right now.
Okay, do you know my email? rehoyt@gmail.com?
Okay.
Yeah, if you would, I would appreciate it. But I think probably I will give all of you a draft copy of the book. So that way you can go back to a previous chapter. All right.
That would be spectacular.
Any other comments or concerns? Okay, let me write down. Okay,
Thank you for everything, Bob. Appreciate it.
okay, you're very welcome, and I'll see you next month. If you have any other concerns, just email me.
Thank you. I just typed a question. Can I read it?
Sure.
I was wondering if you could prepare a practical exercise demonstrating a simple text mining task using PubMed or Twitter for the next or another session.
Okay, different than the one I just did. I'm not sure what you mean.
For example, we can mine COVID and treatment for the last 5 years and determine a compare different data. Is it possible?
I'll look at it, but again, certainly, if you're talking, I'm not sure what else you can get out of it other than, positive and negative comments and so forth. But you want to see something in PubMed Mind?
Yes,
All right. Well, I will look at it and see. Okay.
thank you.
All right, Bob, I'll stop the recording.